All right, here's assignment 1-1. First questions have to do with limits. So we're going to talk about it and then we'll put the answers down. What's the limit as x approaches -4 of f at x? So here's -4. The limit is the y value there, so the answer is -2. So let's write down the assignment. Let's write down the question. The limit as x approaches -4 of f at x, and then write down the answer. And the answer is -2. Number 2, the question is, what's the limit as x approaches -1 of f at x? Let's look off the graph and find where -1 is. And what's the y value there? And you can see the y value there is +1. What's the limit as x approaches 0 of f at x? So at 0, we do have a hole, but if I look at the left and I look at the right, what's the y value that it's approaching? So when we get there, it's a hole, but what's the y value that it's approaching? And the answer is 2. What's the limit? No, this is a function question. What's the value at 0? There's a hole there, so it doesn't exist. Oh no, there's a point below. I didn't see it. So there's a hole here, but underneath there's a point. What's the y value here at the point? And it's -1, so scratch that out. Number 5, the limit as x approaches 0 from the left. So as x approaches 0 from the left, the answer is 2. Number 6, what is the limit as x approaches 1 of f at x? There is 1. There's an asymptote. So at an asymptote, the limit doesn't exist. Number 7. What's the function value at 1? Well, there's an asymptote, so it doesn't exist at an asymptote. Number 8. What's the limit as x approaches 2 of f at x? So the limit value, there's a jump at 2, so it doesn't exist. Number 9. What's the limit as x approaches 2 from the left of f at x? So from the left, the y value up here is 2. You could trace it from the left and get the answer. Number 10. What's the limit as x approaches 2 from the right? So 2 from the right, the y value from the right is -2. Number 11, f at 2. So the function value at 2, the y value here, which is 2. Number 12, what's the value of the limit as x approaches 4? So from the right and left, what's the y value here? It's 0. Number 13, what's the limit value as x approaches 4 from the right? Well, it's continuous, so from the right or left, it's the same answer. It is 0. So those are your limit questions. For number 14, you're given piecewise that you need to graph. So let me write that down. So how am I going to graph this? So let's start with 0. If I plug 0 into the top piece, I get the answer -3. and the slope is 2. So if you like, you're going to go up 2, but we want it from here. So we're going to go down 2 into the left 1. So there's the first piece in terms of what it looks like. I'm going to plug 0 into the bottom piece. I get the answer -3 again. So it's continuous there. I'm going to plug 2 into the middle piece and get -5. 1, 2, 3, 4, 5. So 2 and -5, and then plug 2 into the bottom piece, you get 6. That's going to be a hole, because it's just an arrow, and the slope is 3. So up 3, and to the right 1, and then you have the last part, just like that. Now we're going to answer questions based on what we just drew. So, for number 15, it says, find the limit as x approaches 0 of g at x. So at 0, from the left and right, they both agree. What's the y value right there? And the answer is -3. 16, the limit as x approaches 2 of g at x. So for 2, there's a jump, so the limit doesn't exist at a jump. For number 17, the limit as x approaches 2 from the left. So from the left, it's this y value, which we said was -5. That y value down there. Number 18, the limit as x approaches 2 from the right. So 2 from the right, the y value here is 6. What's the actual function value at 2? That's the closed point, that's -5. And then what's the limit as x approaches -2? Well, for -2, we go into the top piece because -2 is less than or equal to 0. Plug -2 in and get your answer. So -2 times 2 is -4, take away 3, and you have your answer. All right, number 21. In number 21, what's the limit as x approaches 0 of 2x subtract 5? So the first thing I'm looking for is continuity. Is this a continuous function? There's nothing that makes it undefined, so just plug 0 in and you have your answer. Number 22. The limit as x approaches -3, x squared minus 5x plus 4. Again, this is a continuous function. Nothing makes it undefined. So you can just evaluate at -3 and get your answer. So that's 9 plus 15 plus 4. What is that? 28? Yes. I can add. Here we go. 23. 23 is the limit as x approaches 2, and we have 2x subtract 5, and the square root of x plus 7. So first we evaluate. If it's undefined, then we have to do something else. But if we can evaluate it, then we do. So 2 times 2 is 4, and 4 take away 5 is -1. 2 plus 7 is the square root of 9, which is 3. So the answer is -1/3. 24. The limit as x approaches -2, and it's the absolute value of 3x plus 5. Again, this is continuous. Nothing makes it undefined. Plug -2 in. Just make sure you remember what absolute value means. So when you get the answer, the absolute value of -1, the answer at the end is going to be +1. 25. The limit as x approaches 2, 3x subtract 6, the square root of x plus 6. So we're going to evaluate at 2. So 3 times 2 is 6. and 6 take away 6 is 0. So 0 divided by any number, the answer is just going to be 0. 26, the limit as x approaches pi for sine x. So evaluate at pi. Remember your unit circle. Pi is on the left side, and the point there is negative 1, 0. Sine is the y-coordinate, so the answer is 0. 27. The limit as x approaches pi over 2 of cosine x. So we're going to evaluate at pi over 2. Pi over 2 is at the top of the unit circle, so I like sometimes drawing a little picture to remind myself. At the top is 0 and positive 1. Cosine again is the x-coordinate, and the answer is 0. 28. The limit as x approaches pi for tangent x. So again, we're going to evaluate at pi. So we were just there. The point is negative 1, 0. Tangent is the y value over the x value. So 0 divided by negative 1, the answer is 0. 29. The limit as x approaches pi over 2 of cosine 2x. So evaluate at pi over 2. And you get the 2's divide out. It's just pi. The x-coordinate at pi, right here, the x value is negative 1. Done. Number 30. The limit as x approaches 2, cosine pi x over 3. So we're going to evaluate at 2. So that's the value of cosine at 2 pi over 3. I look at the denominator. That tells me it's a 60-degree reference angle, and the order is 1/2 and root 3 over 2. The x-coordinate there is 1/2. In the quadrant, 2 pi over 3 is in quadrant number 2. So we count 1 pi over 3, 2 pi over 3. It's in quadrant number 2, which means the x-coordinate there is negative, so the answer is negative 1/2. 31. The limit as x approaches 3 of secant pi x over 4. So we're going to evaluate again as x approaches 3. So that's secant 3 pi over 4. Now the fun work. 3 pi over 4. That reference angle is 45 degrees. The order of the points is root 2 over 2 and root 2 over 2. The rule for secant is the reciprocal of cosine. So it's the reciprocal of the x-coordinate. So we take the x-coordinate and do the reciprocal. And then the last part is, what quadrant are we in? So we have 1 pi over 4. 2 pi over 4 reduces. And then the next quadrant would be 3 pi over 4. We're in quadrant number 2. And secant, which goes with cosine, which goes with the x-coordinate, is negative in quadrant number 2. And you have your answer. 32. The limit as x approaches 7 of cosecant pi x over 6. So we're going to evaluate at 7. Because we have a 6 in the denominator, it's a 30-degree reference angle. The order of the points there would be root 3 over 2 and 1/2. Cosecant is the reciprocal of the y-coordinate. It goes with sine. So the reciprocal of 1/2 is 2. What quadrant are we in? 1 pi over 6, 2 over 6, 3 over 6, 4 over 6. The next is 5, 6 over 6, and the next is 7. We're in quadrant number 3. And in quadrant number 3, the y-coordinate is negative, so this answer is negative 2. 33. The limit as x approaches pi of cotangent x over 6. So we're going to evaluate there because it's continuous. Let's go through it again. The denominator, it's a 6. So that means it's a 30-degree reference angle. That's root 3 over 2 and 1/2. Cotangent, by rule, is the reciprocal of tangent, which would be y over x, but it's the reciprocal, so it's x over y. So I have the x over the y. The denominators would cross out, so this is root 3 over 1. The quadrant we're in for 1 pi over 6 is quadrant number 1, where everything is positive. And you have your answer. 34. One more like this. I think you're okay with one more only. As x approaches 5 pi. So evaluate. That's cosine 5 pi over 3. Because it's 3 in the denominator, it's a 60-degree reference angle. The point at 60 is 1/2 and root 3 over 2. The rule for cosine is the x-coordinate. So the answer is 1/2. Now, is it positive 1/2 or negative 1/2? So 1 pi over 3, 2 over 3, 3 over 3 we skip, 4 over 3, and then finally 5 over 3. We're in this quadrant. That's quadrant number 4. And the x-coordinate in quadrant number 4 is positive. So the answer is positive 1/2. Number 35. What's the value of the limit as x approaches 2 from the right of f at x? So in this question, you're given a piecewise. 2 from the right would be the bottom piece. So from the right would be greater than, and we plug 2 into the bottom piece only. So that would be 4 times 2, subtract 2 to the 4. So that's 8, take away 16, which is negative 8. What's the value of the limit as x approaches 2? Well, for this one, the top piece and the bottom piece have to give you the same answer. So the top piece is 12. 2 to the exponent 3 is 8. So 3 times 8 is 24. So for me to understand this, I'm first going to find what it is from the left and just do that work. So 6 times 2, take away 3 times 2 cubed. So from the left, I get 12, take away 24. That's negative 12. Because those answers aren't the same, the limit does not exist. There's a jump when x approaches 2. All right, number 36. We just did 36. We just did 36. 37. In 37, you have a piecewise function. And it says find the limit as x approaches pi from the left of g at x. Or is it from the right? Maybe my eyesight's like going. Is that a plus sign? That's a plus sign. All right. So from the right. So when I look at this in terms of pi, from the right would be the bottom piece. So I'm going to write down secant. It's 11x over 6. So that when we evaluate it, it'll be 11 pi over 6. And then that's the answer we need to come up with. Now, if it's over 6, that's a 30-degree reference angle. That is root 3 over 2 and 1/2. Secant is the x-coordinate, but it's the reciprocal. And then the last step is to know what quadrant it's in. So we have 1 pi over 6, 5 pi over 6, 7 pi over 6, and 11. We're right here in quadrant number 4, where it's a positive value. The x-coordinate is positive, So the answer is positive 2 over root 3. Number 38. How about the other direction? The limit as x approaches pi from the left. So now we're going to take the top piece and evaluate at pi. There it is. And so how do I evaluate this? 3 pi over 2 is actually on the axes at the bottom of the unit circle. The point down there is 0 and negative 1. Sine is the y value down there. So that's 2 times negative 1. That's negative 2. 39. The limit as x approaches pi of g at x. So now we look at the two answers. One answer was 2 over root 3. The other answer was negative 2. There's a jump. So at pi, the limit does not exist because the left side does not agree with the right side. Number 40. These are step functions or greatest integer functions. I find the easiest way to do is this. That when you evaluate at an integer, it doesn't exist. Now, to the left means we take a step down. So if I plug 3 in, 3 take away 1 is 2, but from the left it's a step down, so the answer is 1. The limit as x approaches 3 from the right, that one is what it says. So from the right, you plug 3 in and you get the answer 2. Oh, I'm not even doing the right ones. That's 46 and 47. Well, I'm going to do 46 and 47. You can do this too. 46 and 47. I'll come back to the ones I skipped. 48. The limit as x approaches 3. So when you plug in and get an answer, there's a jump, right? The left side doesn't agree with the right side. So at 3, it doesn't exist. It's only a one-sided limit. For 49, the limit as x approaches 3 of x over 2 minus 1. I want you to notice when you plug 3 in, it doesn't give you an answer that's an integer. So the answer is what it says. So we're going to plug 3 in. That's 1.5 take away 1. So that's just 1/2 when you subtract. Number 50, the limit as x approaches 3 from the left of 4x minus 1. So if I plug 3 in, 12 take away 1 is 11. But from the left, I go one step down. So that's why the answer is 10. All right, I'm going to go back to the ones I skipped. Silly me. So the ones I skipped were number 40. I probably didn't do it on purpose. So for number 40, the limit as x approaches 2 of g at x. So for this one, you just evaluate at 2 because it's a continuous function, and you have your answer. So that's 12 take away 10. That's 2. These are easier than they look. Again, just substitute 1 into f for the limit value because it's continuous at 1. A cube function is a continuous function, period. So 3 plus 5, the cube root of 8. What number 3 times itself is 8? So that's 2. The limit as x approaches 3. Oh, look at this. This one is a composite one where one gets composed inside the other. So first plug 3 inside of g. What answer do you get? So 3 squared is 9. Let's do this in 2 steps here. So that's 27, take away 15. What is that, 12? And then take that answer and then plug it into f. So that's the cube root of 3 times 15 plus 5. So 3 times 15 is 45 plus 5. What's 12? Huh. Okay, 3 times 12 is 36 plus 5, so it's the cube root of 41. All right, 43. So the limit as x approaches 3 of h at x equals 5. The limit as x approaches 3 of k at x is 3. And so here are some properties of limits that you can do arithmetic here. So the limit as x approaches 3 of h at x plus k at x. So you have both values. You're just adding these together. So the answer is 8. For number 44, you're multiplying them together. So 5 times 3, that's 15. Here we're going to divide it. So h divided by k, that's 5/3. All right, I already did. Did I? I did 46 to 50. So now we're on 51, whatever order I'm going in. So in 51, it says identify the x values that show to be so identify the x values where there's a discontinuity, they're discontinuous, and classify it as removable or non-removable, which means does the limit exist or does it not exist? So the first discontinuity is at 0. Does the limit exist here? Yes. So it is removable. So I'm going to do this, removable and non-removable, and create a little list here. So when x equals 0, it's removable. Where's another discontinuity? So at the asymptote, that's at 1. So limit doesn't exist at asymptote, so it's non-removable. And here, there's a jump. So the limit doesn't exist at a jump. So at 2, it's a discontinuity. Again, what makes it, does the limit exist or not exist, is what makes it removable or non-removable. 52. Find all discontinuities for the following functions and classify them as removable or non-removable. Don't use a calculator. All right. Last part of our work. So both pieces are continuous. The only way there'd be a discontinuity is if you plug -2 in and you get two different answers. So if I plug -2 into the top piece, what answer do I get? And into the bottom piece, what answer do I get? So if I plug -2 into the top piece, -2, that's -24 and -8. So -8, 3. So -24 and -8. Into the bottom piece, -2 to the 4 is 16. It's positive. So one's negative and one's positive. So at x equals -2, there is a non-removable discontinuity because there's a jump there. And the reason it's non-removable is because the limit does not exist at a jump. These answers are different, so it's non-removable, and there's a discontinuity there. 53. So at positive 2, if I do the same work, you get the answer 32 on top. At positive 2 on the bottom, you get the answer 32 again. You get the same answer, plugging 2 into the top and 2 into the bottom. There are no discontinuities for 53. 54. 2 sine pi x over 2 cosine pi x over 3. So there are no discontinuities for each piece, but I need to plug 1 into the top and see what the answer is. So if I plug in 1 for x, it's pi over 2. The value of sine at pi over 2, that's at the top of the unit circle. That point there is 0, 1. The y value there is positive 1. If I, into the bottom piece, plug 1 in and I get pi over 3, I can already tell these are two different answers. So there is a discontinuity at x equals 1. And there are two different answers here. So one is 2 and the other is half. So at x equals 1, there is a non-removable discontinuity. Again, why is it called non-removable? Because the limit doesn't exist there. And there's a jump, because there's two different answers here. 55. So we have three pieces here. So we're going to look at 0 first. If I plug 0 into the top, the value of cosine at 0, that's this point here on the right. That's the angle. Cosine goes to the x-coordinate. So the x-coordinate is positive 1. The answer is 1. Plug 0 into the bottom piece and you get 1. So there is no discontinuity there. Plug 2 into the top and you get the answer negative 1. If I plug 2 into the bottom piece, the 2's cross out and I'm at pi. Pi is on the left side. The y-coordinate there is 0. So the top middle piece, when you plug in 2, gives you negative 1. This piece gives you 0. So there's a discontinuity at x equals 2. Again, it's non-removable because the limit does not exist. What? We're done our assignment. No, we're not. Why am I saying that? 56 and 57. Then we're done. I'll get all excited because I really want these to be done in less than an hour. So I look at the time and go, did I get it done in less than an hour? 56. There's a discontinuity. This is a greatest integer function. So at every integer, there is a non-removable discontinuity. And again, at every integer, there's a jump in the graph, which creates a non-removable discontinuity. Limit doesn't exist at a jump. All right, one more here. So it's only when there's an integer answer that there's a jump. So not every number gives you an integer. So x divided by 3 would be every multiple of 3 would give you an integer. And we're done. All right, Mr. G Math over and out. You know I'm proud of you for doing your work. I know this wasn't easy. I hope you keep working with me and keep asking me questions. Mr. G Math, over and out.